Hey guys, we're going to do a second video here on surface area. Hopefully you watched the previous video about surface area of a rectangular prism because that's really the introduction video to all of this. But in this particular video, we're going to focus on triangular prisms. So we're thinking 3D shapes that have a base, like a top and a bottom, made of a triangle. And my drawing skills of these are not as great as maybe a lot of yours are, so I've already printed one out that we can just take a look at. And I'm going to zoom in a little bit so we can all see it on the screen here. And feel free, your drawing skills may be a little better than mine, so pause the video and sketch this in your notes so you have a picture that looks like this. But here's what we're working with. We're working with a 3D shape, and if you pay very close attention, the bottom of this shape and the top of this three-dimensional object is a triangle. So what we're going to do is we are going to find what's called the surface area. We want to know what's the area of the entire thing. If I was to paint the object, I would have to paint every single side, and we call those sides faces. So what's the area of each face? And I'm going to do this similar to how I did it in the last video, where I'm going to look at the top, the bottom, the front, the back, and kind of picture it that way. Let's start with the top and bottom first. I think that might be an easy beginning step here. So, taking a look at our picture, we have a triangle on top that looks like this. There we go. And our triangle, which I'm going to draw over here, has a measurement of 10 feet and 5 feet. So this is 10 feet and 5 feet. And we're going a little bit with the assumption here that we're going to need to figure out what the area of this thing is. So we know to find area of a triangle, we are going to need base times height divided by 2. Base times height divided by 2. So our job is to figure out what's the base and what's the height. Now, initially, I want to say it's 5 and 10. But if I pay close attention, remember how we find height. Height has to be at a 90-degree, perfect 90-degree angle. And although I would think this is a 90-degree angle, it kind of looks like it, if I look closer at the picture, it's not marked as a 90-degree angle. What is marked as a 90-degree angle is right here. There's my 90, and it's going from here to here. So I'm picturing that must be the height of my actual shape. So I kind of have to be careful here. It looks like down on the bottom, it's the exact same triangle. Look at that. Here's that same triangle. I'm going to highlight it now. It too measures 10 and 5 feet. This would be 10, this would be 5. But it also measures 11 feet over here. And has a 90-degree angle measuring 4.5 feet. And that goes from here to here, basically. So actually, I kind of have to picture turning it completely sideways. I hope I'm not confusing you with this. But this is my 4.5 feet. That's my height. The height has to be where the 90 is. So here's my height. This is going to be my base. So originally, I really thought I was going to use the 10 and the 5. I'm actually not. I'm going to be using this 11 foot and 4.5 foot. That looks like base and height. So I'm going to turn it back. This triangle was a little bit deceiving when I looked at it, but now I get it. So this is going to be our base. And our height's going to be where the 90-degree angle is. So the area of this triangle, let's figure this out. Base times height, so it's going to be 11 times 4.5, and then divided by 2. And we'll do some quick calculations. Feel free, you can use your calculator if you want. I'm going to do 11 times 4.5. Oops. 49.5. So we are going to take the area of 49.5, and we're going to divide it by 2. Divide by 2. And we're going to get 24.75. 24.75. Okay, so the area of the top and the bottom is 24.75. And to make my work look at least a tiny bit better, I'm going to label this. This is the top and the bottom. All right. And we're not done with this shape. So we still have to deal with a couple more things. The faces that wrap around the object, the sides of it. And if you look closely, there's not exactly a front, back, left, right. It's not like a box. So let's look at these faces carefully. I see the front face here, which looks like this. It looks like a rectangle. I'm going to draw it over here. The front of this shape looks like a big rectangle. And if you look very closely at it, it looks like it measures down 12 feet. That'd be here, 12 feet. And it looks like it measures across 11 feet. So that'd be here. So it is a 12 by 11 rectangle. So to find the area, we'll just do 12 times 11. That'll give us the area of that particular rectangle. So real quickly here, 12 times 11 is 132. So we have 132 square feet of area. But that's the only side that looks like that. That's the only face that looks like that. So there's only one of those. The top and the bottom, we have two of these, but we only have one of these. Let's look at the next face on this object. How about here in the background? In the background, I see another rectangle. Might be kind of getting hard to see, so I'm going to shade this one. I'm going to use an orange pencil here. I am looking at the back wall of this object. There, back there. It too is a rectangular shape, so I'm going to call this the back wall. Say the back. And it looks like this. And if you look closely at its dimensions, remember we had measured that it was 10 across here, so it looks like the bottom is 10 feet. It looks like if I had to find how tall it was or the length of it, I would need this line right here. So if it's 10, I need to know how long is that line. Well, it's got to be the same as this line, which is 12. So this is a 12 by 10 rectangle. And a 12 by 10 has an area of 120 when you multiply it. There's one of those. Now there's one more side. The last face we're dealing with is this one right here. I'm going to shade that another color so it kind of stands out to me. So I'm going to make that blue. And that blue face, if you can see it on the screen there, is another rectangle. So that's another back wall. It's kind of off to the right. So I'm going to write back, right side. And it looks like a rectangle. If you look at the measurements, it looks like it goes 5 feet across the top. So I'm going to label it right here, 5 feet. And it also looks like it goes about 12 feet down. So I'm going to say right here, 12 feet. So it's a 5 by 12. So we're going to do 5 times 12, which is 60, has an area of 60. Okay, so we've done a lot of work. Now it's time to get the total surface area of this whole entire object. So we're going to write total surface area, SA, equals. Now let's think about this. First thing we did was we found the top and the bottom, which was the triangle. It had an area of 24.75. 24.75. But there are two of those, top and bottom. So we're going to take that and we're going to times it by 2. Then we found the front wall, then the back wall, and then that back right wall. So we found 3 different faces. The first one was 132, the second one was 120, and the last one we just did was 60. And there's only one of each of those. So our total surface area is all of this added up. So total SA, surface area, equals, well, now it's just a quick, let's throw it in the calculator and see what we get. So we're going to do 2 of the 24.75s plus the 132 plus the 120 plus the 60. And that adds up to, oh, an error. That's funny. 2 times 24.75 plus the 132 plus the 120 plus the 60. There shouldn't be an error. There we go. 361.5. So total surface area is 361.5. And then I need units. So remember, everything was being measured in feet. So we're going to write square feet. And there's our answer. I'm going to circle that one. Or if you'd rather write feet squared like that, you can write it like that also. This means the same as that. So I'm probably going to post a second video on this, but triangular prisms take a little bit of work. You really have to be able to visualize and see the object because you have to see where all those faces are. The triangular top and bottom match up, but all the other faces that go around tend to be different sizes, and you have to carefully pay attention to what are those dimensions and draw them out I think drawing it out really helps. Sometimes coloring it for me really helps so I can see it. And then adding it all up for that total surface area, the whole entire object. What is its area? So look for more videos. I hope that made sense. And thanks for watching, you guys. Bye.